Polynomial and rational functions. In this module, you will learn about polynomial and rational functions. Recall that a function is a relation in which each input is related to exactly one output. Suppose we have a function f that maps a set x to a set y. The set of all inputs of a function is the domain of the function. The set of all possible outputs of a function is the codomain of the function. The set of actual outputs of a function is the range of the function. If x is the input to the function f, then f of x represents the corresponding output. Let's now learn about a polynomial function. A function from a set of real numbers to a set of real numbers defined by f of x equals a sub 0 plus a sub 1x plus a sub 2x square plus so on till a sub nx raised to the power n. In this function, the highest power of the variable is n, so the degree of the polynomial is n, and the coefficient of the term with the highest degree is called a leading coefficient. The leading coefficient a sub n is not 0 because if it would be 0, the degree of the polynomial will no more remain n. Also, the remaining coefficients a sub 0, a sub 1, a sub 2 till a sub n minus 1 are real numbers, and the value of n is a non-negative integer. It can be 0, 1, 2 and so on. These are some examples of polynomial functions. Now look at this function. Is it a polynomial function? No, because the power of the variable in one of the terms is not a non-negative integer. Now to learn some properties of polynomial functions, we will take these two cases of polynomial functions, one with an even degree and the other with an odd degree. Let's begin with a polynomial function with an even degree. Take the function f of x equals x squared and draw its graph. This graph shows that as x increases, y increases, and as x decreases, y increases, so f of x is positive for all values of x. Thus, the domain of this function is the set of all real numbers, and the range is the set of all real numbers greater than or equal to 0. Now look at this function. It has the same even degree but leading coefficient minus 1. Now if we draw a graph for f of x equals minus x squared, we get this graph. This graph shows that as x increases, y decreases, and as x decreases, y decreases. So, f of x is negative for all values of x. Looking at these graphs, we can generalize that both ends of the graph of a polynomial function with even degree either go up or go down. The both ends behave the same way. When the leading coefficient is positive, the two ends go up. When the leading coefficient is negative, the two ends go down. Now let's look at a polynomial function with an odd degree. The simplest polynomial function with an odd degree is f of x equals x. You may know that the graph of this function is a straight line. Next, look at another polynomial function with an odd degree f of x equals x cube. Let's draw its graph. This graph shows that as x increases, y increases, and as x decreases, y decreases. Thus, the domain of this function is a set of real numbers, and the range is also a set of real numbers. Now look at the polynomial function with the same odd degree but leading coefficient -1. Let's draw its graph. This graph shows that as x increases, y decreases, and as x decreases, y increases. Looking at these graphs, we can generalize that in the graph of a polynomial function with an odd degree, one end goes up and the other end goes down. The function behaves differently at both ends. When the leading coefficient is positive, the function increases as x increases and decreases as x decreases. When the leading coefficient is negative, the function decreases as x increases and increases as x decreases. Now let's learn about a rational function. A rational function is a function from a set of real numbers to a set of real numbers defined by f of x equals px upon qx, where px and qx are polynomial functions and qx is not a zero polynomial. Let's take a rational function 1 upon x and draw its graph. The graph shows that domain of the function is the set of all real numbers except for 0, and range is the set of all real numbers except for 0. Also, the graph approaches x and y axis but never reaches these axes. Such lines which a function approaches but never reaches are called asymptotes. This graph has two asymptotes, vertical and horizontal. Here, for x equal to 0, the denominator of the rational function becomes 0. So x equal to 0 is a vertical asymptote. Now if we compare the degree of numerator and denominator in the rational function, the degree of the numerator is smaller than that of the denominator. In such rational functions, y equal to 0 is a horizontal asymptote. In this module, you have learnt about polynomial and rational functions.